Hello gentlemen, welcome back. We need to continue talking about some trig stuff, and we're going to look at arc length, area, and linear and angular speed, and do a couple examples. So let's get started. Let's first define what arc length is. Arc length of a sector is equal to r times theta. In other words, if I want to know the length of this sector, okay, if I want to know how long it is, I simply multiply r by the radius times the angle theta measured in radians. We have to remember that it's always measured in radians. Okay, so for a lot of these equations that we're going to use, we need to make sure that we have theta in radians. And so basically, if I took a piece of string and I just put it along that right there, and I wanted to know how long that piece of string was, I could use that equation right there. Okay, let's do a simple example. Find the length of an arc of a circle of radius 3 with a central angle of 45 degrees. Okay, so first thing we should know is this 45 degrees needs to get converted to radians. And we know how to do that from the last video. We take 45 degrees and we multiply it by pi radians over 180. And again, remember this ratio right here is equal to 1. So I'm not changing anything. I'm just going from degrees to radians. And if I do that, I get pi over 4 radians. Okay? And now I can simply plug in to my equation for arc length, S, is equal to r times theta, which is 3 meters, times pi over 4, which is equal to 3 pi over 4 meters. One thing I didn't mention before is I want you to understand that radians is sort of a holder. It's really not a unit. It's not a dimension at all. Because if you look at, if you have theta equals, and again, let me just write it out here, S over R, these have the same unit. So radians is sort of dimensionless, but we put it there so it doesn't feel awkward. In other words, if I say, what is your angle, and we just say 5, we need to know that we're talking about a radian measure or a degree measure. We need to understand what we're looking at. But in terms of multiplying, we have a meters times a radians. The radians goes away, and we're just simply left with meters. I know that's a little bit confusing, but just understand that when we're using this equation, R and S here, the radius and the arc length, are going to have the same units. Okay? Let's keep going here. Let's talk about linear and angular speed. Okay? Linear speed is going to be the arc length over time, and this is going to be some sort of length unit, like a meter per second or a mile per hour or something along those nature. Whereas an angular speed is telling me how fast is the angle changing, and that's going to be typically going to be in either revolutions per second or revolutions per minute or radians per second or radians per minute. Okay, and this is for an object moving along a circular arc. So if I'm going around like this, like a Ferris wheel or something, or a car driving around in a circle or something like that, at a constant speed. So understand that we're also at a constant speed here. Okay, so we have linear speed is arc length over time. Angular speed is central angle over time. How much of an angle did I map out in that certain amount of time? Let's do an example. I have a carousel with a 50-foot diameter, makes 4 revolutions per minute. I want to find the angular speed of that carousel. Okay, and so what I need to do, remember that angular speed was equal to theta over time. All right, and I know I made 4 revolutions in 1 minute. So the question is, how do I convert revolutions right there into radians? Well, that's not too bad, because if I'm making 4 revolutions per minute, and this is actually an angular speed, but I want it in radians per minute. So I have to convert revolutions to radians. And what you should know is that there are 2 pi radians in 1 revolution. And what a revolution is that if I start here and I come all the way around and I get back to my starting point, well, in order to do that, I've gone around as 2 pi radians. And so this is the conversion factor here. And again, that conversion factor has a ratio of 1. I'm not changing anything, but all I did here was cancel out my revolutions, and now I'm going to be left in radians per minute. Okay? So understand the conversion between radians and revolutions. The other thing we'd be interested in looking at is the linear speed. Okay, the linear speed is going to be the distance traveled. Remember, it's distance, basically it's distance or arc length, distance over time, which is the same as arc length. How fast is a point on the rim of the carousel moving? And so to do that, again, I have 4 revolutions. I want to know how far, in terms of length, meters, did I travel. Well, 4 revolutions, 1 revolution, if you think about it, is equal to the perimeter. And this is the perimeter, okay, or the circumference of the circle. All right, so if I'm a point on this circle up here, okay, whoops. If I'm a point and I wanted to measure the distance I went, the linear distance all the way around here, the linear distance all the way around, that's the circumference, okay? And circumference is 2 pi r feet, and that's in 1 revolution. Again, this ratio is equal to 1. So what this is going to tell me, in 4 revolutions, I'm going to travel 200 pi feet, because here r is equal to, oh, let's see, we have 50-foot diameter. So this should actually be, yeah, so this is 25 times, r here is 25, is 25. So 25 times 2 is 50, so I have 50 pi times 4, which is 200 feet. That's how far I've traveled. How long did it take me to travel that far? It took me a minute. And so my linear speed is going to be 200 pi feet per minute. Okay? Hopefully you guys understand that. Area of a sector is 1/2 r squared theta. Obviously, if it was a complete circle, we know it's pi r squared. But if I wanted to just know what that area is, it's 1/2 r squared theta. Okay, so the area of a sector is given by this equation here. And again, my theta is in radians. So let's do a quick example. Find the area of a sector with a radius of 2.5 meters and a central angle of 225 degrees. Well, first thing I have to do is convert that 225 degrees to radians. Again, that ratio is equal to 1. That's just my conversion factor. Once I know my angle theta in radians, I know my radius, I can simply plug in and I get a value of 12.27 meters squared. Again, area is going to be in length squared. Whatever the unit of r is, I'm going to square it. So here my unit was meters. I'm going to square meters and get meters squared. Let's look at another example. Car's windshield wiper rotates 125 degrees. The total length of the wiper mechanism is 25 inches and wipes the windshield over a distance of 14 inches. Find the area covered. Well, let's look at a diagram here. So I have 25 inches, but the wiper is only 14 inches long, and it's going to rotate through 125 degrees. And basically, when I want to know how much area is covered by the wiper, so the wiper is going to come like that, and it's going to come like that, and I want to know what all that area is on the inside. Okay. First thing I obviously have to do is convert that 125 degrees into radians. We should be getting really good at that right now. Again, my conversion factor there is 1. I simplify down, I get 25 pi over 36. And so basically what I want to do now is I want to use this equation. Now I got big R squared minus little r squared. What is going on there? Well, if I think about just looking at the area equals 1/2, let's say I look at 25 inches, okay, and I'm going to square that, and times my 25 pi over 36. That's going to give me the entire area, including this part right there. But I don't want that part. I only want this upper part. So what I'm going to do is I'm going to calculate that total area. That's what this part right there is going to do. That's going to calculate the total area. That's going to calculate everything here. Okay? And then what I'm going to do is I'm going to subtract from that Okay, I'm going to take that total area and I'm going to subtract from it the part that's in here. And that's what that subtraction. Okay, and then that's going to give me the part that I want, and that's what this part is right here. Okay, so this is the total area, this is subtracting the small part in the beginning, and that should give me my total area. Okay, and if I do that all out, I get 549.8 inches squared. Okay, here's some practice. Here's finish reading that section 4.1. Here's some good examples. Here's some more practice problems for you guys to do, a couple word problems at the end. These have to do with arc length, area of sectors, and linear and angular speed. Okay? Do some practice here. If you have any questions, email me. Again, the major focus of this was arc length, linear and angular velocity, and areas of sectors, and then we used it to solve some more problems. Okay, gentlemen? Have a nice day.